I want to apologize up front. This could get kind of messy anyway, because I'm using a mouse to write. So we'll see. If something is normally distributed, ooh, this ain't looking very normal. I told you it could get messy. If something is, yeah, this takes some skill, normally distributed. And you know what? It's worth taking the time to slow down and see this, because if it's not normally distributed, then you can't use what I'm about to show you, or at least all of it. Okay, but if it's normally distributed, and let's say that PSAT scores are normally distributed, so when we see that, we kind of know we can move ahead with this little model that I'm about to show you. And let's say they have a mean, that's mu, of 500, and a standard deviation of 85. All right, so what I want to advocate is that you draw a picture to represent the problem, because this will enhance your solutions at the end and really make sure that you kind of capture everything. All right, so a picture would indicate that, and you don't have to do a whole lot here, you just have to indicate that it's normally distributed with that picture, and that it has a mean of 500, and that it has a standard deviation of 85. Whew, I told you it's going to be bad. All right, so a mean of 85. What proportion of students scored below 464? Well, if the mean is at 500, and that obviously is in the middle in a nice normally distributed set of data, then I don't know exactly where 464 is, but I'm just going to roughly put it in. The important part is that you put it on the left of the mean, because 464 is less than the mean of 500, and they were asking what percent of students scored below that. All right, so what we're going to do is, now that we know that we're looking for the area under the normal curve to the left of 464, we can begin our process. All right, and we're going to first of all standardize, and standardize. Yeah, I know this is painful, but watch this. You're going to think this is a mess up, but I made the word standardize with a giant Z, because what you're going to do is the Z-score formula. And the Z-score formula says take the score that you're looking at specifically and subtract it from the mean and divide that result by the standard deviation. So we're going to basically take 464, which is the score in question from our picture, and we're going to subtract the 500. That'll tell us how far it is from the mean. And then we're going to divide that by the standard deviation, which was 85, and that's going to give us what we call a Z-score. You knew that. It's how many standard deviations away from the mean. This one is going to come out negative. Negative 36 divided by 85, which apparently is negative 0.41. And I say that because I included a table where a Z-score, it looks like I'm looking up negative 0.41. Check with my handy dandy calculator, and it turned out to be negative 0.42. All right, so there's this table that we can ask, and I'm going to say ask the table. All right, so we can ask the table. Ooh, there it is. Here's a table, and it's a Z-score table. But you know, in some recent videos I've seen, they say, God, this is kind of old school. So we're going to stop there. We're going to get our calculator. I'm going to kind of verbally walk you through it. So you're going to have your calculator out here. So grab a calculator, pause this video, and let's go from there. So I hope you got your calculator out. So instead of asking the table, which I will be glad to show some folks how to use that if we feel like it's necessary, but really I want to ask the calculator. And so I'm going to kind of come over here. That's why I created a little bit of extra space over here. And again, a little messy, but see if you can have your calculator out. And I want you to use the second key. That's the blue one. So second and vars. But if you look, it's called vars as in variables. But if you look at the vars key, you'll see distribution written over it in blue. Okay, so it's really the distribution key that we're interested in. And when you go there, then I want you to go down to number 2. It should be labeled normal CDF. All right, let's see if I can get this in here. Normal CDF. all right? And when you go to normal CDF, you're going to have four options: a lower, an upper, the mean, mu. I'll just put mean here, and then the standard deviation. All right, those are the choices that you'll have, and that's what you'll enter. All right. And so for the lower, it's the lower boundary. All right. And the lower boundary, well, what's the lowest SAT score you can, PSAT score you can get? Well, I don't know, but you know what? We're just going to put 0 in there. Or, you know, honestly, a better number to put in there is going to be negative 99999, just a bunch of nines. All that's going to do is ensure that no matter what context we're using, that we've got the lowest possible value. And I know there's an argument here with the PSAT thing. You could put 0 and that would work fine. And it would work fine in this case. All right, the upper boundary that we're going to put in is the 464. All right, the 464 that's in our problem, with a mean of 500 and a standard deviation of 85. And then you're going to hit enter. And it will show the kind of a summary of the command you're about to do, and you hit enter again, and it will give you the answer, the proportion of students that score below a 464. The last step you're going to do, I know it's magic, is you're going to tell, that's not tab, that's tell your answer. All right, so tell answer, and specifically in context. Oh, this is terrible. All right, so in context, you get the idea. And so an example of an answer in context is that I don't have my calculator with me, so that's why I can't really show you this. But whatever that answer is, I know it's under 50% because we're below the mean and we're talking about the lower boundary there. I'm going to assume it's somewhere around, let's say, 35%. So you would say something to the effect of the proportion of students that scored below a 464 was 0.35 or 35% or whatever the real number is. Okay. Students that scored above 715, well, we would basically put in the same information, and I would indicate that 715 was on the right this time, and that I was interested in the students that scored above 715, so I would indicate that was this component over here. So I do my z-score, and you might ask at this point, and it's a valid question, is why are we going to find our z-score if we're not even going to use it over here? Well, it's kind of old school. Let's jump back to this other problem. And so when we got a z-score of negative 0.42, then I want you to go over here and hit second distribution again, normal CDF, and for the lower boundary, I want you to put that negative 99999 in again. For the upper boundary this time, I want you to put negative 0.42. All right, and then for the mean, well, the mean of z-scores, if you get an average z-score, you get a 0. And the standard deviation is 1 because we've seen we draw boundaries at +1 and -1 standard deviations from the mean. Put that in there and see what you get. Is it not the same thing that we got when we put the contextual stuff in here, the PSAT scores with their mean and standard deviation? Well, a z-score, you can do that as well, as long as you put 0 and 1, and you're going to get the same answer as this. So anyway, if you have context, you can skip the z-score. But, you know, if they ask you to calculate a z-score and then answer the question, you need to do the z-score. So it would be 715 minus the 500. You got it from there, divided by the 85. I'm trying to, oh, wow, this is difficult. So we're not going to do the table. We're going to calculate a z-score. It must be something like 2.52 or something, because that's what this part of this table I have. But I want you to go to the calculator and enter second distribution. The lower boundary this time is not going to be the negative 99999. It's going to be 715. That's my lower boundary over here is at 715. But I want to go to the upper boundary of the, well, this time I'm going to put 9999999, a bunch of nines. That was annoying. Positive, you know, not negative. All right. And then a mean of 500 and standard deviation of 85. And magically, you're going to get the answer and you're going to tell it in context. All right, I have really boogered this thing up, but I'm sure yours looks better. The last one is to find a proportion between 464 and 715. And you're seeing that I'm drawing the picture just to get an indication of, oh, you know what? I'm looking at between these values. Okay, so this is a good way to go before you start monkeying around with the calculator. So I'm looking at that. It's like a bad heartbeat or something. And then I can standardize, but I'm going to get two z-scores because I'm looking at between, and I'm going to get this z-score right there and the same one I got up there. So no need to do that. We're not going to use the table. We're going to go to second distribution, normal CDF, number 2, and the lower boundary this time is going to be the 464, and the upper boundary is going to be the 715. And we're going to put in the mean of 500, and the standard deviation of 85, and it's going to tell us what's in between there. And then we're going to give a nice contextual answer that the proportion of students scored between 464 and 715 was point whatever blah, or given a percentage. All right. Nice. Thank you for bearing with me, and I hope yours doesn't look as bad as mine. Now you should be able to answer some of the questions on our assignment.